In the second experiment, I completed the MATLAB courses called Simulink On-Ramp and Simscape On-Ramp, and these courses introduced me how the MATLAB can be used to model and simulate dynamic systems. In Simulink, I learned how to create block diagrams to represent mathematical models of systems instead of writing long equations. And I also practiced connecting different blocks such as an input signals, gain blocks, and output display to observe how the system behaves. And my experiment output shows the complete models and simulations that demonstrate how signals move through the systems and produce results in scopes and or graphs. And during the experiment, the main thing I did was follow the guided activities in the MATLAB on-ramp training. And first, I created simple models in Simulink by dragging and connecting blocks to form a working system. And I tested the system by running the simulation and observing the output on the scope. And after that, in Simscape on-ramp, I explored how to simulate physical systems such as mechanical or electrical components. And these allowed me to understand how MATLAB can represent real-world systems using simulation tools. And one challenge I experienced while doing the experiment was understanding how each block interacts with others in the model. And at first, it was confusing to know where to connect certain blocks and how changing parameters would affect the output. And it also took some time to understand the difference between Simulink models and Simscape physical modeling. And however, after practicing and experimenting with the blocks, it became clearer how the system behaves during simulations. And one important note to myself from this experiment is that simulation tools like MATLAB, Simulink, and Simscape are very powerful for engineers because they allow us to test systems before implementing them in real life. And these experiments also reminded me that understanding the concept behind each block is important, not just connecting them randomly. In the future, I can use these tools for analyzing control systems, electrical circuits, and other engineering applications.